you by thesis123.com. I learn and teach online.
Here's the next question, number 49. A three-phase 11 kV 50 Hz two-pole star-connected cylindrical rotor synchronous motor is connected to a 11 kV 50 Hz source. Its synchronous reactance is 50 ohms per phase and its stator resistance is negligible. The motor has a constant field excitation. At a particular load torque, its stator current is 100 amps at unity power factor. If the load torque is increased so that the stator current is 120 amps, then the load angle at this load is dash. Alright, first step, let's put down all that's given to us. We have been given that this is a three-phase 11 kV 50 Hz two-pole star-connected cylindrical rotor synchronous motor. So that is for the motor. Next we have our source. Our source is 11 kV 50 Hz. This is the motor. This is the source. Next we have synchronous reactance given to us as 50 ohm per phase. So that's XS, 50 ohm per phase. And we have also been given the stator current. The stator current is I1, we'll call that I1, 100 amps at unity power factor, which means that cos phi is equal to 1. And we are also given that the stator current is increased to 120. So I2 is 120 amps. We need to find out the load angle. Now since we are to find out the load angle, we need to work the problem out in polar coordinate form, and it is very important that we be careful with all the formulas that we are going to use. Okay, so the first step, we are going to start with the excitation formula. The question says that the motor has a constant field excitation, so we are going to start with that. So the excitation, the field excitation is given by the equation EF bar is equal to terminal voltage minus JIAXS. Please make a note of this equation, quite important. This is the field excitation equation. Now let's enter the values of the voltage, the current and XS given to us. So EF would now equal to, what's our voltage given? The voltage, terminal voltage is 11 kV. 11,000 divided by root 3. We have to remember here and be very careful because XS is given in terms of per phase. So we have to note that down in terms of per phase. So VT is 11,000 divided by root 3 minus J. Current is 100 and XS is 50. Solving this, we get a value of 6,350.85. That's this portion here, minus 5,000 J. We have this in rectangular form. So next, we write it down in polar form. So when you convert it into polar form, you would get a value of 80. Now that's 8,082.9 with an angle of minus 38.21. Alright, so this is the value of the field excitation. So the question says that the load torque is increased. If the load torque is increased so that the stator current is 120 amps. Now the fact is that if the load torque increases, what happens to the power factor? Now the power factor is unity according to the question. So when the load torque increases, the power factor becomes lagging. That's an important point here. So when the load torque increases, the power factor becomes lagging. So in this case, unity power factor changes to lagging power factor. Now it is because of this point we choose our next formula. You should know that the field excitation when the power factor is lagging is Vt square plus Ia square xs square minus 2 into Ia xs Vt sin phi whole under root. Please make note of this equation. This is an important equation where the field excitation, in order for the power factor to be lagging, is taken into consideration. Now the question says that the load torque has increased, but it doesn't say anything about the excitation. So the excitation is constant, or I believe it is said that it has constant excitation. Yes. If you see the statement here, right in the center, the motor has a constant field excitation. So mod EF is constant. Now we use this equation here, substitute the value of EF here and the values of Vt, Ia. Now here the Ia has increased, okay, the load torque has increased, therefore the current has now increased. It's given that I2 is 120, right? So this is Ia2 or I2. Xs is the same, and here as well this is I2 value. Now I'm going to put the values in. Please note, we are going to use the magnitude alone. So that's 8082.9. Now since this part has a root, I can square on both sides. So EF square is now equal to Vt. We noted that Vt is 11,000 divided by root 3 square plus Ia is now 120 square, Xs is 50 square minus 2 into 120 into 50 into Vt. Vt is again 11,000 divided by root 3 into sin phi. We need the value of phi because we are trying to find out what here? We are trying to find out the load angle. This is not the load angle, mind you. We use this in order to find out the load angle. The load angle is the angle of the field EMF. We'll come to that. So first we solve this equation here to find out what is the value of phi. Now that very same equation, I am just going to isolate phi. Please note, phi is then equal to sine inverse of, this is going to be a little large, please note, minus 8082.9 square plus Vt square, 11,000 divided by root 3 whole square plus, next is I square xs square. So 120 square, 50 square whole divided by 2 into I into xs into Vt. So phi is sine inverse of that entire part. So all I have done is just isolated phi from the equation at the very bottom there. Now when you solve this entire portion, you should get a value of sine inverse 0.1443. So you can pause the video, and if you want to solve it, and then check if your value is 0.1443. So the next part is phi being 8.296, that is sine inverse of 0.1443 is 8.296. Now this is phi. Alright, so we'll keep this aside. Now the next step is to go back to the formula of EF. Now I'm going to write down the equation here. That's EF is equal to VT angle 0 minus JIAXS. Please make note of this equation here. This is quite important. This is the equation for the field excitation of the motor in terms of the terminal voltage, the armature current and the synchronous reactance. Now in this case, for this question, all we have to do is plug in the values of VT, IA and XS. So VT is given to us in the question as, look at the source there, it's 11 kV. 11,000 divided by root 3. Why is it divided by root 3? Because we want it in terms of per phase. Now here the synchronous reactance is given as 50 ohms per phase. So we have to have everything in terms of per phase. Okay. IA is I2, which is 120, since that is what has been given there, 120, and XS is 50 ohms per phase. Now let's plug in all of these values here and find out what EF is. 11,000 divided by root 3 minus J into 120 into 50. So the value we get here is 6,350.85 minus J 6,000. Now, just as I mentioned earlier, we have to write this in terms of polar coordinates. So, converting this into polar form, you would get 8736.89 angle minus 47.26. So, what is the load angle here? The load angle is the angle of the field excitation, this. So the load angle delta is minus 47.26. So let's note that down here. Minus 47.26. This is the final answer and the entire explanation. I hope it has helped.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.